Good morning. Today we're going to be looking at dividing polynomials, section 4.6. This will be the last section in chapter 4, so I'm just reminding you to continue to get prepared for your test that's going to be next week. So our objectives for today are to learn how to divide polynomials. In this chapter we've talked about how to multiply and divide monomial terms using our exponent rules. We have learned how to add and subtract two polynomials to each other. We've learned how to multiply polynomials to each other. Today we're going to talk about dividing. We're going to do two different types of problems. A polynomial, which is two or more terms divided by a monomial, which is one term. And then we will be dividing a polynomial, two or more terms, by a binomial, two terms exactly. So to divide a polynomial by a monomial, the rule says that anytime you have a term on the top of a fraction that has more than one term, but you've got one common denominator, each one of our terms can be separated into its own fraction over the common denominator. So a plus b over c is equivalent to a over c plus b over c. The same thing happens if we are subtracting in the numerator. Term A can be put over C, and then we will subtract term B over C. If we can separate each term in the top over the common denominator, then we can simplify each one of these fractions using our exponent rules. So if we're going to take this problem, this is 1, 2, 3 term polynomial divided by a common denominator. So if we've got 3 terms in the top, we should be able to set up 3 individual fractions. 18x squared y over 6xy. We will subtract 6xy over 6xy, and then we can add 12y over 6xy. Then we will take each one of those fractions and simplify it using our, in this case, division rules of exponents. So 18 over 6 is 3 over 1. So we've got a 3 in the top. We could put a 1 in the bottom, but we don't have to. X squared over x, we have one more x in the top. And our y's, there are no more. They cancel each other out. So we've got the term 3x. Okay. Minus 6xy over 6xy. Anytime your numerator and your denominator match, that simplifies to 1. And plus 12y over 6xy. 12 over 6 is 2. We've got one more x on the bottom, and our y's will cancel. So if we clean this up a little bit, we have 3x minus 1 plus 2 over x. That would be our final answer, because none of those are like terms that can be combined by addition or subtraction. So let's look at another one. We have to recognize that we are dividing by one term, so a polynomial by a monomial. Again, we've got 3 terms in the top, so we should be able to create 3 new fractions that we can simplify. The first term over the common denominator AAB, plus the second term 6AB over 8AB, minus the last term 4B over 8AB. And then we will simplify each of those. 24 divided by 8 is 3 over 1, or just 3. A squared over A, I have more A's in the top and I have one more. B squared over B, again I got more B's in the top, so and one more. So this reduces to the term 3AB. Okay, plus 16 divided by 8 is 2. My A's cancel, my B's cancel, so my second term reduces to 2. 4b over 8ab, 4 over 8 reduces to 1/2. I've got one more a in the bottom, and my b's will cancel. So I've got 3ab plus 2 minus 1 over 2a. I want to take a second and just review the process of long division with numbers. This fraction reads 1,192 over 5, which is the same thing as 1,192 divided by 5. We're going to review this process of long division because the next division of polynomials, where a polynomials divided by a binomial will take on this exact same process. So when we long divide, we ask ourselves, how many times does 5 go into 1? Well, it doesn't, so we move on to the next one. How many times does 5 go into 11? 5 goes into 11 twice, so I'm going to put that number right above that digit of 11. And then I multiply these. 2 times 5 gives us 10. Those two numbers always get subtracted. So 11 minus 10 is 1. Next step is to carry down the next number, which is a 9, making it 19, and repeat the process again. How many times does 5 go into 19? It goes into it 3 times, so I'm going to place that number above the 9, and then multiply. 3 times 5 is 15, and again those numbers get subtracted. 19 minus 15 is 4. Carry down the next digit, which is 2. How many times does 5 go into 42? That is 8. 8 times 5 gives me 40. Subtract those numbers again, and I'm left with 2. Now there is no digit to slide down anymore, so that means this is my remainder. When we were really little, we would say that this answer was 238 remainder 2. Now that we are older, we can understand that we can make 238 groups of 5 out of 1,192, and we have 2 of the groups of 5 left over. So this equals the mixed number 238 and 2/5. My remainder of 2 becomes my fraction of the 5 groups of 5 I'm trying to make. Okay. Reviewed that process because when our denominator is a 2-term polynomial, we actually have to use that exact same process of long division. Okay, so x squared minus 5x plus 8 divided by x minus 3. I'm actually going to write this as long division. X squared minus 5x plus 8 is being divided by x minus 3. Now when we do this process, we need to make sure the top polynomial has every term possible from the highest exponent term down to the integer. So this would be x squared, x to the first, and our numbers, which is the same thing as x to the 0 power. So because those are consistent in descending order, I don't have to add any terms to this polynomial. Okay. So now when we start the division process, this is the only part of our divisor that we are concerned about. This poor -3 just has to go along with whatever we decide with this x. So we're going to do the same thing. We're going to ask ourselves, how many times does x go into x squared? Or x times what will give us x squared? Okay, we should all agree that x times x will give us x squared. So we're going to place that x directly above the x term, and then we're going to multiply. X times x gives us x squared. X times -3 is -3x. Just like the other process, we are going to subtract these polynomials. Okay. If we've done this correctly, these terms should always cancel out. X squared minus x squared does cancel. Okay, so -5 minus -3 gives us -2x. And we slide down the plus 8. And we repeat the process again. X times what gives us the term -2x? Well, that is -2. So -2 times x is -2x. -2 times -3 is +6. We subtract those terms. -2x minus -2x gives us 0. 8 minus 6 gives us 2. We have no other digits to slide down, so that means we have a remainder of 2. That 2 is positive, so we are going to, since these are polynomials, we are going to add our remainder of 2 as the top of my fraction, and my divisor was x minus 3. So my answer is x minus 2 plus 2 over x minus 3. Hopefully that makes some sense to you. Okay. Let's move on to the next example. I'm going to give you some time to set this up. Make sure that your terms in the top, since it's starting with 3, we have to have a cube term, a squared term, a regular x term, and then numbers. We do have that, so we do not have to add any other terms into our divisor. Okay, so we can set this up. 6x cubed plus x squared minus 18x plus 10. I'm going to move that down so I don't get in the way of my words. Move it down just a little bit. 6x cubed plus x squared minus 18x plus 10, and that is going to divide by 3x minus 4. Okay, so again, we are concerned with this part of the divisor only. So 3x times what gives us the term 6x cubed? Well, 3 times 2 gives us 6, and x times x squared gives us x cubed. Notice I put my answer right above the squared term. So 2x squared times 3x gives me 6x cubed. 2x squared times negative 4 gives me negative 8x squared. And we subtract those two polynomials. 6x cubed minus 6x cubed does cancel that out, which is what I want. 1x squared minus negative 8x squared actually gives us 9x squared. Drop down our next term of negative 18x. Repeat the process. 3 times what gives us 9x squared? Well, 3 times 3, positive 3 gives us positive 9, so 3 times 3 gives us 9, and x times x will give us x squared. So 3x times 3x is 9x squared. 3x times negative 4 is negative 12x. Subtract our binomial terms. 9x squared minus 9x squared cancels. Negative 18 minus negative 12 gives us negative 6x. Carry down the positive 10. Okay, and repeat again. 3x times what gives us negative 6x? That would be negative 2. Negative 2 times positive 3x is negative 6x. Negative 2 times negative 4 is positive 8. And we will subtract those two terms. Negative 6x minus negative 6x is 0, and 10 minus 8 is 2. Again, I've got a positive remainder, so we are going to add 2 of the groups 3x minus 4. So my answer to this division problem is 2x squared plus 3x minus 2 plus 2 over 3x minus 4. And one last one. Polynomial by a binomial. Again, my denominator is more than one term, so I know I have to use long division. 2x plus 4 is on the outside. Okay. This is the first time where we have a problem. My highest x squared term is x squared, but I have no x's before I get to a number. In order for this process to work, if my highest exponent is a 2, I have to have an x term in there. Since I have none of them, I'm going to make a placeholder of 0 x's between the x squared and the number. Okay? And then I'm going to do the division again. 2x times what gives me 4x squared? That's going to be 2x, so I put it above that x term that I put in there as my placeholder. 2x times 2x is 4x squared. 2x times 4 is positive 8x. Subtract the terms. 4x squared minus 4x squared gives me 0, which is what I want. 0 x's minus 8 x's is negative 8 x's. Carry down the negative 16. 2x times negative 4 gives me negative 8x. Negative 4 times 2x is our negative 8x. Negative 4 times positive 4 is negative 16. Subtract those. Negative 8x minus negative 8x gives me 0. Negative 16 minus negative 16 also gives me 0. This time I have no remainder, so my answer is simply 2x minus 4. Okay, your homework for class on your case will be Monday is to complete the 4.6 My Math Lab assignment and also complete the 4.4 and 4.5 multiplying polynomials ICA. Have a good day.